Hi guys, Algebra 1, Unit 1, Lesson 1, Reasoning Numerically. Now our objective here is students will reason quantitatively to show real-world problems involving rates, including unit rates, and reporting accurate units. Now when they talk about rates, they're really just talking about percentage. So for example, let's say 73% of students in high school graduate high school, okay? Now when we're talking about unit rates, what we're really referring to is, well, we have 73 graduates for every 100 students who are enrolled. Okay. Now, reporting accurate units, let's say there was a government survey or census and it got reported on the news or a newspaper or even just in someone's argument. And then in their argument, they say, well, only 70% of students graduate high school, and that's because they weren't being accurate. So basically, they said, well, we typed in the calculator, and for some odd reason, they just wrote down this. Okay, that's an example of not being accurate. What is supposed to be accurate is you type this in your calculator, and you get 0.73. Now, accuracy can really matter, especially if we're talking about tens or hundreds of thousands or even millions of students. If you were to exclude that 3, you could be excluding 3,000, 30,000, 300,000, or even 3 million people. So be very careful with that. Now, your turn. Find and rate the graduation rate for high school students. So let me add this part in here for high school students for California. So go ahead and use Google, look it up, check with your group, see what other data you got. Find the rate, okay, just like how I did in my example right here of graduates in California. And then after you find that rate, I want you to go ahead and rewrite it as a unit rate, like I did in my example, and try to report as accurately as possible. Okay, so pay attention to all the numbers that you may get. All right, your turn number 2. Solve the following percent problems. Round to the nearest hundredth and incorrect units of measurement. So what I mean here is in this situation for part A, we have 80%. Now 80% can also be written as 0.80 times $200, or you can do, again, that's 0.08 times $200, or you could do 80 out of 100 times 200, or if you know that 80 divided by 10 could be reduced as 8 over 10 times 200, or if you want to reduce even more, you would know that 4 over 5 times $200 will get you the same answer as all the rest. So just be aware that there's many different ways you can represent your situation to get the same answer. Now, correct units of measurements, of course, this answer is going to be in dollars. So your answer is going to be in dollars. Miles, your answer is going to be in miles. Feet, your answer will be in feet. Language objective. Demonstrate to a partner how to use dimensional analysis. Now, don't be thwarted by the word dimensional analysis. You've seen it before. For example, let's say we were taking a trip that took us 75 minutes on a freeway or something like that. And you're like, how many hours is that? And basically, you can use dimensional analysis to do that. We know that for every 1 hour, we have 60 minutes. This is an example of dimensional analysis. So these minutes will cross cancel, and all you're left with is 75 hour over 60. Okay, the minutes cross canceled. If you type 75 and divide it by 60 in your calculator, you should be able to get 1.25, and that'll be in hours. And this is another way of saying, well, 1.25 hours. All right, now your turn for number 3, I want you to use dimensional analysis, just like I did in my example, and convert 92 inches to feet. Okay, and try to be accurate if you need to be accurate. While using dimensional analysis, this is part B, convert 90 minutes to hours. All right, our definitions. Precision is the level of detail of a measurement determined by the smallest unit or fraction of a unit that can be reasonably measured. So as you can see here in our little image, this person designed this entire thing being very precise. He used very, very precise measurements. He didn't measure by meters, okay, because, well, that's probably not going to be as precise. But everything's so small here, okay, even this little churn here is 90 degree, but everything is so small, it's got to be, okay, for it to work. So that's what we're talking about. Now for your churn, number 4, what is more precise, 1 foot or 12 inches, and why? Base your argument off the definition that I gave you up here. All right, definitions continued. Accuracy is the closeness to the actual measurement. So your turn, number 5. Which is more accurate to say? 81 divided by 100 equals 0.8, or 81 divided by 100 equals 0.81. Why? Okay, make sure you use the definition and your own thoughts. Okay, how can you word it with your group? All right, thank you, and enjoy.